All right, let's talk about good old GitHub. So once you've got a GitHub account set up, you're going to be pushing and pulling remotes, and you probably don't want to type in your password all the time. So one way you can prevent having to type your password is to use the magic of public-private key pairs. But first, we kind of got to understand what this is. So luckily, in the world, we have mathematicians. They have figured out a way to take large random numbers and a key generation program and produce public-private key pairs. These are related. This is like a gross oversimplification, but they're related kind of like with a one-way function where it's easy to compute in one direction, but hard to compute with another in the other direction. So if I give you two like 300-digit prime numbers, you can multiply them together and produce, I don't know, what's that, a 600-digit number or something like that. It would be tedious, but you could do it. But if I give you like a 400-digit prime number and I tell you it's the product of two extreme, 200-digit primes or whatever it is, that factoring it into what those gigantic prime numbers is really hard. So easy to compute in one direction, very hard to compute in another. Just very, very computationally expensive because it's an exponential problem, essentially. So that's more or less what happens. So you produce these two keys that are related through the wizardry of math. Now, how does this help you? Well, let me tell you. So if Bob and Alice want to talk, and this is a standard crypto thing, Alice and Bob, A and B, are always communicating. And then Eve, the eavesdropper, E, is always trying to listen in on them. So if Bob wants to talk to Alice, suppose Alice has a public-private key pair. Alice makes her public key available. Anybody that wants knows what Alice's public key is. They can get access to it. It's all fine. What Bob's going to do to send Alice a secret message is take his message and encrypt it with Alice's key to produce, essentially random gunk. Now, only Alice's private key can decrypt that. Alice's public key can't decrypt that. Just the private key can to get back the original message, which was hello, Alice, right? This is the wizardry of public-private key pairs. How does this work? Number theory, discrete number theory, and math. That's how it works. I don't know. I took crypto in 2001, so I only vaguely remember this, but it's math. It's pretty well understood math, but it doesn't matter that it's well understood because it's based on the fact that factoring is difficult. So this is what happens. Now, how does this help us communicate with GitHub without a password? Well, you, the SSH user, you're like, hey, I want to connect with you, server. Here's my public key, so you know it's me. And it's going to go, hey, that looks like the key I have on file. I've got that public key on file. I'm going to encrypt the message, right? So the server generates some random bits and encrypts it with your public key. Now, only your private key can decrypt that. And then it sends you the encrypted whatever, right? And if you figure out what it says, we can connect. And so you take your private key. You don't do this. I mean, the software does this for you. Decrypts that message with your private key. And if the string you send back to the server is whatever the server encrypted with your public key, it's going to know, yep, that person has either a very large quantum computer, which doesn't currently exist, or they've got the private key that corresponds to this public key. So I'm talking to the person who says that they are, as near as we can tell, using the wonders of mathematics. So I'm not going to make you type in a password or authenticate in any other way. You've authenticated using the wonders of public-private key pairs, right? So that's how, basically, on GitHub, you don't need to type in your password. So what does this mean for us? Well, let's generate a public-private key pair. I realize now I'm going to need a terminal, which, oh, you know what? I'll run it in VS Code. Do I have VS Code over here? Hold on. VS Code, where are you? Da, 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 da. Ha, I do have one over here. Good. Just making sure. Hold on. What is going? Yeah, there we go. Good. All right, great. Pretend that part didn't happen. All right, so how do we do this? Well, we go over here to good old GitHub. You might not be able to see this, but this is my little face. This is a really old Xbox Live icon from like 2011 or 2010. I don't even know if I could generate this anymore with Xbox Live. I probably can't. I need a better avatar. Somebody help me with that. Okay, so I click on this. I come down here to settings, click on that. And then in settings, I go down to SSH and GPG keys. So SSH keys, I would say, oh, I want to put in a new SSH key. So I can name it whatever I want. pick a better name. Let's just go with authentication key. Now we got to figure out what to put in here. Here's what we're going to do. So we're going to come over to here and I'm going to open up a terminal. Whoop. Oh, look at that. I'll have to update this later. Go away. Boop. Okay, good. Now, well, you know what? I don't remember the command. So we ask, there we go. SSH. Well, you know what? I'm going to do this. GitHub generate SSH key. Yeah, just so it tells me what to do. It gives you the command. Yeah, there we go. This is what they're doing these days, is all of this nonsense. So I'm going to just, so I've opened up my terminal because I'm on Mac. I can just plug this in. This will almost certainly just be there. I can put whatever email address I want in here. jspacko@knox.edu. This is the name of the keygen algorithm. If this one doesn't work, just do -RSA. RSA is the standard, you know, classic encryption algorithm for crypto that goes back to the 70s. So I'm going to run this. It's going to go, and it's going to go, hey, where do you want to put this? So this path, users Jamie Spacko, that's my home directory. .ssh. Dot just means like hidden configuration folder. It's a Linux, Unix, Mac convention. Windows will probably just use that, but it's not really a Windows convention. Doesn't really matter. And then this is going to be the name of the private key. The public key will be just this.pub. I think that's a perfectly legit name. For passphrase, I'm going to not put a passphrase in. I'm going to hit enter twice. And so I get this, I don't know, whatever this little dealio is. Now, if I cd into twiddle/.ssh, on Windows, I think that command will look basically the same, assuming that you have SSH keygen installed. If you don't, Google how to install SSH keygen. I think that command's going to look pretty much the same. For this, on Windows, it would be something more like cd, like c:\.ssh, or maybe it's // or maybe it's like this. I don't know. Or you could just do to this, you know, c:\, and then once you're there, cd into .ssh. But get into that folder on Mac. I know I can do twiddle.ssh, or I can just hit cd enter to go to my home directory, and then .ssh. And I can always use tab to complete. Type just enough characters to make it unique, ss, and then hit tab, and it'll complete it for me. And if I go in here and do ls, on Windows, it would be dir. Mac, obviously, Mac Linux doesn't know what this is. I've got a whole bunch of these keys. This is the one I just generated. That's the private key, and that is the public key. So what I would do is I would open this up. You can open, I mean, I can do cat. That's one way to open it. Right? That just can cat basically means concatenate to the screen. On Windows, open it with like Notepad or WordPad or something like that. I also on a Mac or Linux, if I have this configured, I can actually just open it with code. Code means open it with VS Code, and it'll just pop it open here. And what you would do is you would just copy all of this. You'd come back over here to wherever you had this open. You would plunk this in. This is an authentication key. I don't know. I'm going to call this the new one. I don't know why I'm going to name it that. Add SSH key. Make sure you're signed in. It's going to ask me to do, oh no, it isn't. Huh, look at that. Boom. And now I've got these two in there, right? I've put these both in. This old key, this SHA-256, this goes back to probably 2004, probably earlier, 2002. I might need to remake this one. I don't know. Anyway, so you've got this set up. So this has the public version, and then I've got the private version. And if I look at my permissions in here, ls-l, you'll see that by default, all of the private keys, the ones that don't have .pub after them, they're read-write for me, but they're not readable or writable by group or other. And that's just a security thing. So I have, I don't know, I have a whole bunch of keys in here. I have Minecraft, PEMS. I don't even know what half this stuff is. The ones I really care about are the IDRSA and IDRSA pub. That's my old RSA key. And then I guess this new one I just made. Get Kraken. I don't even remember why I had that there. Probably I just do something like this for Get Kraken. Anyway, this video is going on way too long. But to go back to, here, boom. That's how to set everything up. Great. That video was way too long, but Hopefully that's helpful. Now, when you do Git commands, Git push, Git pull from command line or from GitHub desktop, it should just work. You shouldn't have to type in your password all the time.